Hi everyone, we're going to analyze the graph of a rational function in number 13, 14, and 15. This is 14. These are the ones with the holes. So the first thing I'm going to do is factor when you x plus 3 or x plus 2 times x plus 3 over x plus 3. I'm going to first find the domain. The domain is all real numbers, but x cannot be negative 3. So you plug in negative 3 in the denominator here. You said that can't be 0, then x can't be negative 3. Now normally when we come down and locate the vertical asymptotes, each 0 here gives rise to a vertical asymptote. But this case we have a hole, so we have no vertical asymptotes. So no vertical asymptotes. Instead, we're going to have a hole, and we'll talk about that. Alright? It's not in reduced terms. To reduce this, you would cancel this out. Right? And the degree in the numerator, in fact, what we're going to end up having is r of x equals x plus 2, which is just the line. Okay? So basically, from here we can answer all this, especially since we just have a line here. So it makes it pretty easy. The x-intercept of y equals x plus 2 would mean that y is 0. So x is negative 2. Negative 2 plus 2 is 0. And our y-intercept is when you let x be 0. So when x is 0, we get 2. And then on this one, if you plug in everything, we don't want to worry about that. There's no vertical asymptote, but we know in reduced form we have a hole, because remember we had x plus 2 Okay, so basically you can cross those out. That means we have a hole at negative 3. Alright? That means in the domain x can't be negative 3. So that's what we're going to have a hole. You plug in negative 3 back into the reduced equation, which would be right here, and you're going to get negative 1. So there's where your hole is. And I think everyone knows how to graph this, so there's an oblique asymptote, but it happens to be the same thing as this, so I'm not going to worry about that. And we're going to go ahead and just graph this because it's just a line. Everyone knows how to graph this, so it's y equals x plus 2. It's right here. The y-intercept at 0, 2. The x-intercept at 0, negative 2, or negative 2, 0, sorry. We had a hole at negative 3, 1. So that's negative 3, negative 1, actually. And you just draw your line. And that's your graph. That's also your oblique asymptote. It's right on top of each other, so that's it. Thank you. Have a nice day. Bye-bye.